The second question that we have appeared in JEE some time back. They always try to test a lot of things in a single question, so they have put in 4 options. The first part is the coordination number of each type of ion in CaCl crystal is 8. So for solving this question, you must first know the structure of CaCl. The structure of CaCl is body centered cubic. You should remember this, with Cl minus ions located on the corners and Cs plus ion at the center. Therefore, we have Cl minus at these points and Cs plus ion at the center. This is Cs plus and the others are Cl minus. Now, to find out the coordination number, let us first see what happens. In body centered cubic, we have a structure like this is the top view of these 4 ions, these 4 Cl minus ions. Then below this will be Cs plus ion which is touching all these 4, and below that will be another similar layer of 4 chlorine minus ions. So the structure appears something like this from top. So we can clearly see that for the Cs plus ion, it is touching 4 Cl minus ions on top and 4 Cl minus ions below. That means the coordination number of Cs plus is 8. Now for Cl minus ion, let us look at this Cl minus ion. This Cl minus ion is touching this Cs plus ion. It is not being seen in this picture, but it can be seen in this picture. The Cl minus ion is touching Cs plus ion. It is not touching the other Cl minus ion. In this picture, it can be clearly seen that this Cl minus ion is not touching this one or this one. Therefore, the only atom it touches is Cs plus ion in this unit cell. Now, just like this unit cell, there will be another unit cell beside this, like here and here and here in the downward direction. So for all these 4 unit cells, this Cl minus ion will touch the Cs plus ions in all these 4 unit cells. Now above these 4 unit cells, there will be another 4 unit cells which will have this as a corner atom again. Therefore this Cl minus ion will touch 4 Cs plus atoms in the above 4 unit cells also. Therefore in all, this Cl minus ion will touch 8 Cs plus ions. Therefore the coordination number of Cl minus will be 8 and Cs plus will be 8. Now similar to this Cl minus ion, all other chlorine minus ions will have a coordination number of 8. Therefore coordination number of each type of ion in CaCl crystal is 8 is a true statement. Now for the B part, it is written that metal that crystallizes in BCC structure has coordination number equal to 12. This is completely false, because as we have just seen, in a BCC structure, even when this atom is the same, even then it will touch only 8 atoms. Therefore the coordination number equal to 12 is not possible. Therefore this is false. In the C part, it is written that unit cell of an ionic crystal shares some of its ions with other unit cells. This is completely true, because as we had already seen, the Cl minus ions which were there in the previous part were shared. This is a unit cell. This Cl minus ion was also shared by the unit cell which was behind this. By this unit cell, it was also shared by the unit cell just beside this and on this diagonal corner, and 4 other unit cells on top of these 4 unit cells. Therefore, the ions are definitely shared and our C part is correct. Now for the fourth part, it is given that the length of unit cell in NaCl is 552 picometers. So for this again you need to know the structure of NaCl, which you should remember as face centered cubic. Now in this FCC of NaCl, the Cl minus ions are located at the face centers and the corners. Let me draw it. These are the Cl minus ions. There is another Cl minus ion over here. And apart from these Cl minus ions, there are also Cl minus ions on the face centers. This is the Cl minus ion on the front face and this is the Cl minus ion on the corner of the behind corner. Now, apart from these Cl minus ions, the Na plus ions occupy the octahedral voids. So the octahedral voids are present here along the H centers and also at the center. So let us consider the H centers. Now when we consider the H center, we know that the octahedral voids, the maximum radius of an atom which can fit in the octahedral void is R is equal to 0.414 into R, where R is the radius of the atom constituting the lattice, which in this case is Cl minus ion. This is equal to 0.414 into 181 picometers. This is less than 90 picometers, but the radius of Na plus ion is 95 picometers. Therefore, they do not fit in the octahedral voids. The sizes are actually Cl minus ion like this, Na plus ion like this, and Cl minus ion like this. So what has happened is that these Cl minus ions must have moved apart to accommodate this Na plus ion. So this becomes one edge now. Now to find out the length of this unit cell, it is clearly equal to 2 times radius of Cl minus plus radius of Na plus. This is equal to 2 times 95 plus 181 picometers. That is equal to 552 picometers, which is given over there, and therefore our D option is also correct. That is the length of unit cell in NaCl is 552 picometers. To solve this part, you must have known that NaCl has face centered cubic structure with Cl minus ions at the corners and the face centers, and the Na plus ions occupy the octahedral voids at the H centers. The octahedral voids in a FCC structure are located at the H centers and at the center of the lattice, but we considered this to find out the edge length, which came out to be 552 picometers, and our D option is correct. So final answer is A, C and D are the correct options.